So let's continue our Riemann sum, trapezoidal sum, rewind, and look at the midpoint Riemann sum. This is the only one where you should know your shortcut formula. All right, we'll talk. We have rocket A. It has a velocity after being launched upward, so it's going up. Remember, this is AB, so that means its y of t is going to be positioning. With an initial height of 0 feet at t is equal to 0. It's being launched off the ground. So we have feet per second. You know I always like to write my units to the right. The velocity of the rocket is recorded for selected time intervals from 0 to 80 seconds as shown in the table above. Okay, this one will probably be quicker. Find the average acceleration of the rocket A over the time interval from 0 to 80 seconds. Indicate units of measure. All right, so here we go. Average acceleration of rocket A over 0 less than or equal to t less than or equal to 80. Well, before we do that, you need to understand average value of a function fundamentals, right? So if I want to take the average value of the acceleration, so the average acceleration of the rocket, right, I want to do 1 over b minus a, 1 over 80, times the integral from 0 to 80 of my acceleration function. But I think a lot of you, especially if you've had some physics too, I know a lot of you don't take physics and calc, but some do. Well, I guess there is a good crossover there. But anyway, a lot of you would know to just say, oh, 1 over 80, so b minus a is down here. The integral of acceleration is velocity, and then if I use FTC, I'm going to plug in my 80 to my velocity, and then plug in my 0 to velocity. So that difference would be in my numerator. Well, that's just the slope of the secant line from 0 to 80 on my velocity graph would be the same thing as my average acceleration. Do you know that? All right, so let's calculate this. We don't get a calculator, remember. V of 80 is 49. V of 0 is 5. All over 80. That gives me 44 all over 80. Divide by 4, that gives me 11 over 20. Now let's talk units, right? Be careful. My velocity units, right, are feet per second. Now this is already per 80. The time interval, right, from 0 to 80 is in seconds. So it's feet per seconds per second. So this would be feet per second squared, if that helps you out. All right. Using correct units, explain the meaning of the integral from 10 to 70. So they're not even having me go from 0 to 80. Just be careful. In terms of the rocket's flight, use a midpoint Riemann sum. Now here we go, with 3 subintervals of equal length to estimate that integral. All right. They want me to explain it first, then find it. So they want me to go the other way. So let's do that. So the integral from 10 to 70 of v of t dt means, and this is my interpretation, it's how much, remember, it's going up, right? So y of t is going to be determining that. So it's the height. So how much height in feet the rocket gains for t is equal to 10 seconds to t is equal to 70 seconds. And again, you should be schooled with equal subintervals now. So you should always then calculate how many subintervals you need. You need 3. You always got to find the width of all of your equal rectangles that you're dumping in, 3 of them, right? B minus A, 70 minus 10 is 60, all over how many subintervals you need, or rectangles. That means you would have a width of 20 going across the x-axis, right, for each of these. Then it's a question, do you know how to build your x sub k's? Now, let's not overthink this. I know my width has to be 20, but I'm building my height from the middle, right? So you could build it that way. My first subinterval is going to be from 10 to 30. Halfway between that is 20. So my first x sub k is 20, but now I can just add my width to that once, and then add a width again to that new 40, which would be 60. Those are where I need my v of 20, v of 40, v of 60 to get the heights of all of my rectangles that have a width of 20. That makes sense. You're going to integrate from 10 to 70 of v of t dt. That's what you're approximating, so you're going to put approximate. Now remember, when you're doing the shortcut formula for Riemann sums, your d always goes out here. And then you're just going to add all these heights, all right? So this is just the shortcut. So I need v of 20 is 22. V of 40 is 35. Just be careful. V of 60 is 44. Now let's think about this. This would be 79 plus 22 is 101. I'll double 101 to 202 and add a 0, so 2020. 2,020 feet. You could double check my work, but I think we're good. That's pretty straightforward. Rocket B is launched upward. So we have rocket A was launched off this. You know they love doing this. They're giving you the acceleration function for rocket B's launch upward. And that's my A of t. Feet per second, same units. At time t is equal to 0, the initial height of the rocket is 0 feet. So my y sub b of 0 is 0. Okay? The initial velocity is 2 feet per second. So my velocity of b at 0 is 2 feet per second. Which of the two rockets is traveling faster at time t is equal to 80? Well, I need to figure, I know what the velocity is of A. Velocity of A of t, or I'm sorry, I don't want t, I want 80. Let's just dump an 80 in here. That's 80. I know that's ugly. I apologize. So the A rocket's velocity at 80 is 49. Yikes, is that ugly? Sorry, that's 80. All right, so I need to figure out the velocity formula. I need to integrate. So my velocity for the B rocket means that I need to integrate that acceleration for rocket B. I won't skip any steps. I'm assuming that you guys are schooled at integrating this kind of stuff. U is equal to t plus 1. du would equal dt. 1 dt, but dt. No adjustment needs to be made. So that would equal 3 all over, well, the integral, sorry, of 3 all over the square root of u du, right? So the velocity of B, and I should have put this in terms of t, I apologize. let's make sure you see that that's equal, is equal to 3u to the negative 1/2 becomes 3u to the 1/2 divided by 1/2 would be 6 square root of u, but use t plus 1. And don't forget your plus c. All right, they gave me a way to get my constant. So the velocity at 0 is 2, so that would be 0 plus 1 is 1, so that would be 6 plus c, so that means my c is equal to a negative 4. So my velocity of rocket B at any time t is equal to 6 root t plus 1 minus 4. So now I can find my velocity of my B rocket at 80. Now watch this. That would just be square root of 81 is 9. 9 times 6 is 54. Minus 4 is 50. All right, so rocket B is traveling faster. Now, normally speed is the absolute value of velocity, but remember, these are both positive, so I don't even need to worry about that. Just be careful. Rocket B is, use their words, traveling faster at t is equal to 80 seconds. Man, is my handwriting getting nasty. All right, t is equal to 80 seconds because v of B of 80, the velocity of rocket B at 80, is greater than the velocity at A of 80. All right, there's a breakdown of a midpoint Riemann sum, but remember, you better be ready to do an equal subinterval on that quickly. Hope that helped you.